All right, welcome to lesson 10.3. This is direction angles of vectors and practical applications of vectors. So there's a lot to cover in this particular unit, and we're going to start off with the unit vector. So a unit vector is a vector u that has the same direction as a given non-zero vector, but it has a length of 1. In other words, we're putting it on the unit circle. And so we place the starting point at origin. The end point is on the circumference of the circle because that, again, is the length is 1. And we can find that unit vector by taking the vector v and dividing it by the magnitude of v. So it has a magnitude of 1, but the same direction as the original vector. So for example, if I was to find the unit vector for vector v with 3 and 4, so the first thing I would need to do is find the magnitude of that vector. And the magnitude of that vector can be found, of course, with the equation x squared plus y squared, and then square root of the whole thing. So again, I have a 3, 4, so 3 squared plus 4 squared equals square root of 25, which is 5. So then my unit vector u is the v value, and that v was 3 comma 4 divided by 5. So then I take the 3 over 5 and 4 over 5. Those are my new x and y pairs that will put my vector on the unit circle, or 1 from the origin. Now we're not required to assess the unit vector as part of this unit, but I wanted to introduce it because it's a great way to show you how we find vector angles. And so we don't need to find the unit vector, but again, when I see it drawn this way, it makes a little bit more sense. And so let's just say that this vector u here, is a unit vector. And so it ends right on that 1 circumference line, right, where the radius is 1. And of course, then I have two coordinate pair x and y, and then the magnitude is 1. So on that unit circle, you remember that if you have an angle theta, that the triangle that is formed, the right triangle that is formed here, has the opposite side is sine of theta, or the y equals sine theta, and the adjacent side, or the x side, equals cosine theta. Like I said, you don't need to convert to a unit vector to be able to find the direction angle. It's just a great illustration for it. What I really just need to find is whatever this y value is and divide it by the x value, and then that's going to give me the tangent theta, right? So tangent theta is sine theta over cosine theta, right? Which is y over x. And we're going to be able to use that throughout the rest of our vector addition. So when we find that angle theta, we're going to need to do some adjustments to it, because what we are going to find is the reference angle. And so let's look at the different options in here. So when I go into quadrant 1, my angle comes out here at theta. And in quadrant 1, my reference angle theta is the angle theta. And so I don't have to adjust it. And so there's nothing to change to it. When I put in a angle for theta in quadrant 2, this theta, remember, I'm going to find it as tangent y over x. But in this case here, my x value is negative. And so when I put in a negative y over x, I'm going to get a negative angle theta. Let's say that this theta came to 30 degrees, then this would equal negative 30 degrees. And I'm going to take that negative 30 degrees and I'm going to add it to 180. All right, so negative 30 plus 180, of course, is 150. And if I look at that from the perspective of starting here at origin, or at 0 and going around to here, that is 150 degrees. So that checks out for me, right? And then if I'm over here in this quadrant here, because my x and y are both negative, my tangent value is going to be positive. And so again, here's my reference angle theta. And going all the way around, I'm going to add 180 plus the reference angle. Okay, so that accounts for these two. And in this last quadrant, once again, I'm going to get a negative theta value, right? I'm going to get this from the reference angle here. Because my y is now negative, my tangent is going to be negative y over positive x, which is going to give me a negative angle theta. And so that negative angle theta plus 360, all right, so 360 plus a negative theta, right, whatever that is going to give me that angle going all the way around back to here, okay? So this does make a little bit of sense. So don't worry about the sign of the angle. Once you adjust it by adding the 180 or 360, or then you should get the right answer. Okay, find the direction angle of the following vectors. So at 3, 3, my my angle is going to be, well, let's just kind of draw where it lays out here. Okay, so here's my coordinate plane. I'm not in the unit circle anymore, just using the coordinate plane. And if I go over 3 and I go up 3, I'm going to have a point right here. And so going from origin out to here, you can tell right away I'm 3 and 3. We know what that means, that my y and my x are equal to each other. Right here and here, this is 3, this is 3. I didn't draw my hashes right, but that's okay. So we know that this is going to be 45 degrees. And how can I prove that? Well, the arc, so remember, it's tangent theta equals 3 over 3. And I could rewrite that as theta, right, equals the arctangent, so tan negative 1, and then 3 divided by 3 is 1, right? And so plug that into your calculator. Well, we know that the sine and cosine are radical 2 over 2 and radical 2 over 2. In other words, they're equal to each other. So we know we're going to get 1. And so my theta, if you type that into the calculator, will be 45 degrees. Okay, let's try one that's not quite so obvious. So going over here, I have vector 3i, 4j. Remember, this is just another way of writing that vector here of 3 and negative 4. Okay, this and this are equivalent ways. They're just different ways of writing the same thing. Sometimes we prefer to use this format when we're adding a bunch of vectors together. It kind of makes a little more sense. All right, so 3 and 4, right? So then tangent theta is my y, right? It was negative 4 over 3. Well, let's graph that real quick. Okay, so at negative 4 and 3, 1, 2, 3, and down 4, 1, 2, 3, 4, right about here. So this would be my graph. This is my reference angle here, theta, right? And then the angle I'm going to achieve is going to start here and go around counterclockwise to this point here, right? So tangent of theta equals negative 4 over 3. So theta then is arctan of negative 4 over 3, which equals negative 53.13 degrees. So now I'm going to take, because I'm in quadrant 4, and you can just do Q4 to show what you're doing here. Because I'm in Q4, theta equals 360 plus negative 53.13. So my theta then is a positive 306.87 degrees. Don't worry, you will get used to that. Okay, don't panic on that one. All right, so again, and just if you draw it out, it makes complete sense, right? I want to find what this length is here. Well, all the way around is 360. So I'm going to take this little value right in here and subtract it from 360, and I will find what's left, the rest of the pie. Okay. So let's find the component forms of vectors. So if I'm not given the x and y value, but I know the length and I know the vector angle, then I can calculate that. Okay, and so here, remember my angle is 210. So if I go all the way around this way here to here, this is 210 degrees. And I have a magnitude of 100 units. Okay, well, I'm going to turn this into a right triangle right here. This is my y and this is my x. This angle theta right here is a, this is 210, right? And this from right here is 180. So 180 degrees here, right? And so 210 minus 180 is 30 degrees. So this theta here for reference angle is 30 degrees. So then I could find this y value is the hypotenuse, right? Opposite over hypotenuse. And so the sine of theta is y over hypotenuse. So I don't know what the y is, right? It's y over the hypotenuse, but the hypotenuse is this magnitude of 100 units. So it's y over 100. So then I could rewrite this to find it for y, and y equals 100 sine theta, okay, or whatever the magnitude is, and that's what this is right here. This is the magnitude of this vector here. So going and the same thing holds for the cosine, right? Because this x value gives me the cosine. So let's go ahead and find those values. So my vector then is 100 cosine theta, or cosine of 30, and 100 sine 30. And they wrote it here as I and j. Could do it. I could do this as I plus j, however you want. Okay. So then remember that the x and y values are negative in quadrant 3. So then this is going to give me a cosine of 210 is, and you could actually put 210 in here. You'll get what you're going to get is the actual negative value, right? The cosine of 210 is negative radical 3 over 2. And so I get 100 times negative radical 3 over 2. And here it's 100 times negative 1/2. And we knew that from our unit circle, right? With that 210 degrees is, it's going to be 7 pi over 6, right? And that's right out of our unit circle as well. So these are my two coordinates. And I can simplify this down to 100 divided by 2 is 50. And so I'm going to get negative 50 radical 3 and negative 50. Those are my component coordinates for this point in here. So if you use the 30 degrees, then just remember which quadrant you're in and that your y and x are negative. If you plug in the full 210, then you'll get the cosine of 210 is negative radical 3 over 2 and negative 1/2 for the sine. Okay. All right, so that's a lot to digest in here, but this is a powerful tool. This is something that engineers use all of the time when we're doing force analysis, right? And you've used this in physics probably, where you've broken down a force vector into two different directions, an x component and a y component. That's how you can add multiple forces together in a free body diagram. So those of you who've already taken physics, you're well familiar with this concept. All right, so find the angle between two vectors. Now that's a really important concept, and to be able to do that, I need to I need to be familiar with a couple of things. Okay, so the first thing is the dot product. Again, the dot product in and of itself is not something that we're testing on, but you need to know how to find the dot product in order to find the angle between two vectors. And so the cosine of the angle between two vectors is the dot product of the two vectors divided by the magnitude of the two vectors multiplied by each other. And so the dot product, again, I take the x's and multiply them together, and the y's, I multiply them together, and then I add them together, and I'm going to get a single number. Okay, I'm not getting a coordinate pair or a delta x and delta y. I'm just getting a single number here for the dot product. And so that's a little bit different than what we've done to this point. So let's try it with an example. So I have two vectors, and I think it's easier to maybe start this by maybe sketching these two vectors that I've got. And so, in fact, I'm going to change this. Stop. So let's try a couple of examples. So I have I want to find the angle between the vector 3, 4 and the vector of 5 and 2.14. And so if I graph those two, I can kind of get an idea of what ballpark I'm looking at. Okay, you can tell, I mean, I can't get an exact, I can't draw that well to get it exact, but I could get at some idea, right? So if I draw a quick Cartesian plane here, and I plot the point 3, 4. So let's go ahead and go out here. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Okay, so 3 and 4, 1, 2, 3, and up 4 is right about here. So this is my first vector right here. That's this vector. That's u. And then my v vector, let's go ahead and use yellow here for that. My v vector is going to be over 5, 1, 2, 3, 4, 5, and then up to 0.14 right about there. Okay, so this is a lot shallower. So that's my second vector. And what I'm trying to find is the angle theta formed between these two points right here. Okay, and how can I find that? Well, first thing I need to do is find the dot product. So the dot product is, remember, it's just a number, right? It takes 3 times 5. It's the x's. So it's the dot product is, so u dot v is 3 times 5 plus 4 times 2.14. Okay, so it's the x multiplied together, the y's multiplied together, and then you just add them. Okay, so that dot product is going to give me a number value, right? I'm going to get 15 plus, and this looks like it's about 8.56. And so that adds up to, so u dot v is 23.56. Okay. Now, we're going to find the two magnitudes. So the magnitude, remember, that's just your x squared plus y squared. We already have the x value here, right? So this one here is 3 squared plus 4 squared, which we know is 25, which equals 5. And the magnitude of v is going to be the square root of 5 squared plus 2.14 squared. And that is going to come to 5.44. Now, let's find the inverse cosine for this, right? So cosine theta, and again, this is right from my formula right here. Cosine theta is my dot product, which is 23.56, over the two magnitudes multiplied together. So 5 times 5.44, which is going to give me 23.56 over 27.19. Okay, remember that's theta, cosine theta. So theta then is the arc cosine of that value. So theta equals cosine and of this value here. And that value is going to give me, let's see, 0.866 or so, which makes theta equal to 30 degrees. And so that is how you find the angle between these two vectors. This theta right in between in here is 30 degrees. All right, lot of material we covered. We still got to go and make it just a little bit more confusing. So we're going to start by getting some nomenclature straight. Okay, so when we talk about vectors, where a lot of times we're using either some nautical terminology or some aeronautical terminology. And being an old air traffic controller, this is really what I'm used to. And so in a compass, we use north at the top at 0 degrees, right? So if I was to make a coordinate out of that, it would look like this, where my 0 is right here. And I know that's going to drive you a little bit nuts, right? So this is my east is 90 degrees. Okay, so right here, if I'm heading 090. So if I was heading 090, I'm going due east. And the opposite of that would be 270. And then south is 180 degrees. Okay, so that is when we talk about headings or bearings, and then the increase as we go around clockwise. And so again, everything that we've done up to this point, now we're going to do the opposite. And again, because the real world scenarios that we deal with and the magnetic north and compasses and all that stuff are completely different than our mathematical world where we have things like the unit circle, etc. So I just want you to get used to that. And so you're going to have to be able to convert back and forth between this type of nomenclature and presentation and then back to your coordinate plane to find these angles. Okay. So that's bearing. There's another way we refer to things. When direction of travel or heading can be given by a vector based on the compass, or it can be given as an angle relative to due north or south. For example, N20E is the way we say that is 20 degrees east of north. Don't blame me, I didn't make up this stuff, okay? So 20 degrees east of north, okay? So I'm going, this is north, and so I'm going to go 20 degrees this way, 20 degrees, okay? Because this is east, and so my vector would be right here. Now, that vector here is heading 0 to 0, or 20 degrees, right? Air traffic control would say 0 to 0. Okay, everything gives in 3 digits. But the angle that we would be doing here, that we deal with, is really 90 degrees, right? Minus 20 is 70 degrees. All right, again, just get used to being able to manipulate these back and forth. That nomenclature can be used for the south as well. 30 degrees east of south. Okay, well, here's south down here. So 30 degrees east of it would be this way, because, I'm sorry, this way here. My apologies, that's west. This is east. See, it's confusing. All right, so 30 degrees east of south then would be here, 30 degrees. And my heading, remember, this is 0, this is 90, and then this is 180 here, right? So 30 degrees from 180 is 150. 150 degrees this way here. Or I could also remember that this is, if this is 30, then this is 60, right? And 90 plus 60 is again 150. So there's a lot of ways you could write that. Your reference angle is 60 degrees here. And if you went all the way around this way, which we're more used to doing, again, don't forget this is 270 plus 30 is 300 degrees, exactly. So lots of different ways of writing this, but all we're going to do is we're going to use this information here to set up our graphs on our coordinate system, And then from then on, we're going to use what you're used to with mathematics. And then when we get our answer, of course, we got to go back and put it back the way we found it, okay? So let's try some examples of this. All right. So a ship sails from port at a heading of 120 degrees. Okay, remember, this is north here. So 120 degrees is down and to the right, right? Because this is 90. So this is 30 degrees right here, okay? And it travels on that heading of 120 for 75 kilometers, okay? So this is point B here. This is the port. Let's call that A. And that's my 30-degree mark there. And I am gone for 75. So this magnitude of this is 75 kilometers. Okay. And then at that point B, I'm going to turn. Okay. And that turn is going to go 220 degrees. Okay. And so 220. Let's see if I've got something keyed up for this or not here. I do. So if I put a little, and you see I've got it in white and I've got it dashed in here. If I put this little dashed cross in here, basically this is like an alternate, just so you can picture what I'm doing now. Okay, assume that this is the new origin, and I'm going to add in this vector with a magnitude of 120 and a heading of 220. All right, so 220 or 220, again, this is 180. So I'm going to continue on this direction here. Remember, this is 270, so I'm between these two. And so my vector is going to go from B out this direction here. Okay, so that's my new vector. And this vector is from here around 220. If this is 180, and this is 220, then the difference between these two is 40 degrees, right? And then this is from my reference edge here, it's 50 degrees. Well, if this is 30 here, then this angle over here also, because these are parallel, right? And so they're alternate interior angles, they're equal to each other. So this angle right here, I'm going to move this 75. It's kind of in my way here. So this angle over here is also 30 degrees right here. So the total angle between these two vectors, I don't have to calculate it, I've got it here, is 80 degrees. So this is how I'm going to find that. I'm going to use the law of cosines, because what it's asking me is find the distance from the port to the ship, and B, the bearing of the ship to the port. So if my ship is right here right now, okay, this is where I'm at. And I want to know is what's this distance here, and what's the direction I need to travel to find that. Okay, all right, so I want to go back. I wasn't sure if I had anything else drawn in here. Okay, so then what do I need to do? Well, first off, find the angle between the vectors. Okay, I did that. That's 80 degrees. Find the distance between the starting and the end point. So the length of this line. If this is side B, this is side C, then this is, angle C, then this is side B, all right? And then my side B squared from the law of cosines, my B squared is A squared plus C squared minus 2AC cosine, and then my angle 80 degrees. Okay, so putting in my value, my A value this is 75. Actually, this side here is C, right? So C is 75. My A value is 120, right? This side right here is 120. So here it's 120 squared minus, and it's 120, 75 cosine 80 degrees. So this is B squared. And so B squared then is, calculator, B equals 100, B equals 130 kilometers. Okay. So now, all right. So that's the magnitude. That's the distance. So that's the first thing I wanted to answer right here. Okay. Okay. So I'm going to find what I really want to find is this angle A right here, because that is going to give me. I can find out my bearing from that. Okay, so which direction I'm heading. Because what I'm going to end up ultimately doing is projecting this line up this way to find this angle, because that is my heading from north, right? And so angle A is, or sine of A over, and then the side length is over here is 120. That was a given. Equals the sine. The only other angle I know for sure is this 80 degrees. So 80 over, and then of course 130, because that's the one we just found. So sine of A is 120 sine 80 over 130. So that would be, let's so throw that into a calculator. So sine of 80 is 0.98 times 120, gives me 118, and then divided by 130 is 0.909. And now I'm going to take the arc sine of that, right? So, because sine A, right? So I want to find the arc sine of that value so I can get angle A. So angle A is going to be arc sine of 909, 65.37 degrees. Okay, that's this angle right here, okay? And now this is what I was talking about before about translating this back into vectors, right? So if I was here and I wanted to tell my pilot or shipmaster which direction to travel, or what is our angle? Well, if this is 65 and this is 30, if I add them together, that's going to give me 95.37. And this 30 degrees starts right here at my due east heading, right, or my x-axis. So that means that from here down to my 270 is 90 degrees, okay? And if I'm at 95, then this little angle here, which is equal to this angle up here, is 95 minus 90, or 5.37 degrees. Okay, that is my, and then if you want to put it that way, this is north and then east, right? So this is 5.37 degrees east of north, okay? And or just 537 degrees. Okay, that is the bearing I'm heading, or the direction I'm traveling to get back to port. Whew, I know, it's a lot. Let's try something else. Okay, so I have an airplane traveling at a speed of 500 miles an hour, and it's bearing 330 degrees at a fixed altitude, negligible wind velocity. But all of a sudden, the plane reaches some point and it incurs wind. And that wind is blowing with a velocity of 70 miles per hour in the direction of 45 east of north. So what is the resultant speed and direction of the airplane? Okay, so this problem here, again, this is really two different vectors combined together. So what am I going to look like? Well, let's see if I've got a graph set up in here or not. I do. Okay, so here's my airplane, and it's heading 030 degrees. Okay, so this is 330 degrees. All right, and just to refresh your memory, remember, this is north, which is 0 degrees, right? So this angle's all the way around this way. Okay, and so remember, this is 270, right? So from the reference edge here, this is 60 degrees right here. Just FYI. Okay, so you kind of get a feel. And then this is the wind. No, that is not the right direction for that wind. All right, I had got ahead of myself in there. That was our result. Our vector for the wind is the green vector down here. Okay, so that vector for the wind, again, I'm going, this one here was a mass or a magnitude of 500. My wind is heading 45 degrees off north. So this direction right here is 45 degrees. And it is a magnitude of 70. Okay. So this is a different type of problem. I want to know is what's the resulting direction of the flight, right? So obviously this plane was going this way, and now it's going to be shifted off to the right a little bit because this wind is blowing it this direction, right? Almost perpendicular to it. And so it's going to drive me to the north a bit. How can I find that? Well, the best way to do is to break these two vectors down into their component forms and then add the components together, like the x's together and the y's together. And I'm sure you've done this before. So let's go ahead and do that. So the vector, let's call this vector p because that's the plane. And then this is going to be vector w, that's the wind. Okay, so the plane is vector p. And that vector is going to be broken down at 500. And I could do this a couple of different ways, but this is my reference angle at 60, well, 60, right? And so if I project this down here to a right triangle, then this is my y value, my x value. And again, my x is going to be cosine of 60 degrees. Or if you prefer, going from origin all the way around here. Either way it works. This is going to be cosine. Let's do it this way here. This is cosine of 120, right? I hate to clutter this up, but for me, all the way around here is 120 degrees, okay? And so this is going to be cosine 120. And my y value is going to be 500 sine of 120 degrees. And then, so that's going to give me negative 250 and 250 radical 3. All right, exact values. Okay, that's right out of the unit circle again. And then my vector p, this angle over here, my reference angle is just 45 degrees, right? And so that one's pretty easy. So this is vector w for wind. How about that? Okay, so let's use vector w, and just to keep my colors consistent. So vector w is going to be 70, because my magnitude is 70, cosine of 45, and 70 sine of 45. And we know those are going to be the same thing, right? And that's going to give me 35 radical 2 and 35 radical 2. All right. We're trying to avoid the calculator, but I'm going to have to use it now because to find the magnitude of the resulting vector, I need to add my two vectors together. So the vector total, my new vector, is vector p plus the wind vector, which if I add the components together, 250 plus 35 radical 2, remember this is negative 250. So I'm going to get, and just trust my calculator work here, I get negative, in fact, I want to go ahead and put this total in a different color. So again, this, let's go here, this is going to be negative 200.5, and estimate, right? Because I've plugged these into a calculator and I had to round, and this is 482.5. This negative carried through on my addition, right? So 250 minus 35 radical 2, and these were both positive, so they added together. All right, and that does make sense, right? Because I'm going up in this y direction positive both times. And so we would expect this y component to be bigger than the original 2. All right, so my vector total then is finding the magnitude of that. From here on out, most of what we do is the same. I want to find the total of this. So I take the square root of negative 200.5 squared plus 482.5 squared. Don't forget that the negative, when you square it, goes away. Okay, so this is no longer negative. You're going to get a positive value. And when I square root this, I'm just going to save some time here, and I get a magnitude of 522.5. And then I'm going to add those units because everything was in miles per hour, right? So this is 522 miles per hour. So we picked up a little tailwind there. That's kind of nice. And then the direction of travel that I could find is going to be found the same way. I'm going to find that theta. And so a tangent theta is the opposite over adjacent, which is a y over x. And so we'll just write it here is theta. We're going to find, I can squeeze it in here, I think. Theta is arctangent of the y value, which was negative. No, it's positive. It's 482.5 over 205.5, 200.5. Now the 200.5 is negative, so that makes my whole thing negative here, right? Because I only have one negative sign. This was the square. I shouldn't have wrote that in there. So then that arctangent value is going to give me a negative result, right? I'm going to get arctangent is, or theta of that is negative 67.4. And I'm in quadrant 2, right? Because my x is negative, my y is positive. So I'm in quadrant 2. So I'm going to add 180 to this. And that's going to give me an angle of 112.6 degrees. All right, so that is this angle from here all the way over. So what's my heading? Well, my heading is taken from true north at 0 here, right? And so from here over, I'm going to subtract 90 from that. Okay, I know so much adding and subtracting, it's confusing. So this vector, actually, I take that back. We're going to be going, that angle is 112 going this way, but my starting from true north going around this way to here, it's going to be somewhere greater than 330, obviously. So let's figure what that would be here. Going from here to here was, okay, so this is, if this is 0, 90 degrees minus this would be 22.6. And so 360 or 0, yeah, 360 minus 22.6 gives me a heading of 337.4 degrees. Okay, so that is my heading based off of north, right? Another way I could have wrote that, and it might be easier, you can see why they do this now, is I am going to be from north 226 degrees west, west of north. Okay, either one of these answers is acceptable because that's the same thing. Okay, I know. I apologize for all the confusion in here, but you start adding vectors and such, that's what you're going to get. Okay, let's try one more problem, I think. Nope, that is it. Enough abuse today. Thank you for your time.